Okay, so we're going to take you through some of the standard features on the Gagemaster product. The software that we use is known as Fusion, and Fusion software runs throughout the product range. All of the models that we have on offer run the same software package. So everything I'm going to be able to talk about today relates to any model in the range. So how does the software work? The way it's laid out is that we have all of the camera related functions on the right hand monitor and all of the reporting and analysis on the left hand monitor. This is a personal preference. We don't have to have two monitors. One monitor is perfectly acceptable, but a lot of our users find this twin monitor approach very convenient. So if we concentrate on the camera side for the moment, I have a bunch of icons here which relate to various features on the image itself. So in this group here I have icons that relate to the method of measurement. So for example, if you have an optical comparator, you might be using a crosshair to target points on a projected image, and I can simulate that using our digital crosshair here. And I have a number of other data collection options here, but because this is a vision system, the biggest advantage is that it has camera-based edge detection. So I'm going to select edge detection for this example because that's the biggest advantage we have over the conventional optical measurement methods. So this is basically how I want to measure, and down here this group of icons is related to what I want to measure. So I have icons for circle, line, arc, point, and so on. I have some more advanced features here which we can get into in another session. But what I want to do is quickly show you how we measure some standard features. If I select a line, then move over to an edge of interest, I can quickly draw a box over this line, and then as I fire the tool, you can see that the camera has scanned from one side of the box to the other, and in this case has taken 160 data points. And because I defined the tool type as a line, it's already calculated the least squares best fit line through those 160 points. Now if I say OK to this now, that would be the end of the measurement, and we move on to the next feature. However, there's more of this line available, so I'm going to simply drag the image across with my right mouse key, and as I release, the stage makes a nice motor controlled move for me and enables me to grab the rest of this image that was not available in the field of view. And you can see on this window here, I've added more data to the currently open measurement, and we now have a longer line made of 283 points. If I OK that now, on the left-hand monitor you can see that we've got a graphical representation of that feature in the position that it was measured on the stage. If I reopen that and hit set reference, you can see that the software chooses the appropriate way to use that feature as a reference feature. In this case, it's orientated itself to the part and rotates that coordinate system to show that that line is now at 0 degrees. So let's move on and measure another feature. I'm going to measure a circle in this case. This time I need 3 clicks to define the tool, and again another scanning width. You can see we've measured a 2mm circle there. It's with 155 data points, and if I OK that and redraw, you can see that to the right of the line I now have a circle. So in very simple terms, the way that this works is to use tools to grab the edges of features that we're interested in. There's no skill involved in this. I'm simply creating tools, creating boxes over the edges and allowing the system to find the edge of the features that we're interested in.